Hello students, this is Lata Narwani from Mount Litra Z School Jhansi. Children, we were doing lesson metals and non-metals, and last turn we had discussed the chemical properties of metals. Today we will be discussing the chemical properties of non-metals. Before the properties of non-metals, we will discuss the reactivity series of metals. In the reactivity series, why are some metals chemically very reactive while others are less reactive? So, the answer to this is in the activity series of metals, the basis of the reactivity of the metals is their tendency of metals to lose electrons. If a metal can lose electrons easily to form positive ions, it will react readily with other substances, therefore it will be more reactive metal. Means if a metal loses electrons and forms a positive ion, it will be more reactive metal. While on the other hand, if a metal loses electrons less rapidly to form a positive ion, it will react slowly with other substances, therefore such a metal will be less reactive. For example, alkali metals like sodium and potassium lose electrons very readily to form positive ions, like Na loses electrons and forms Na plus. Similarly, sodium loses electron, forms potassium loses electron, forms potassium plus. So they are very reactive metals. It may be noted that hydrogen is not a metal, but still it is placed in the reactivity series. What is the reason? The reason is that hydrogen can also lose electron to form H plus ions, hydrogen ions. Secondly, it is kept in the reactivity series to compare the reactivities of metals with respect to hydrogen. Means a metal is more reactive than hydrogen or less reactive than hydrogen. Next topic is chemical properties of non-metals. First, reaction with oxygen. Non-metals react with oxygen to form non-metallic oxides. These oxides are acidic in nature as they dissolve in water to form corresponding acids. And these oxides also turn blue litmus to red. So, let us see the various examples. First, carbon reacts with oxygen, forms carbon dioxide, and when this carbon dioxide is dissolved in water, it forms carbonic acid, which turns blue litmus to red. Similarly, sulfur reacts with oxygen, forms sulfur dioxide, and when sulfur dioxide is dissolved in water, forms sulfurous acid, and this sulfurous acid or SO3 dissolved in water forms sulfuric acid, and they also turn blue litmus to red. So these non-metallic oxides are acidic in nature. Two oxides are also neutral oxides, means they are not acidic. Some non-metallic oxides are neutral in nature. For example, carbon monoxide, nitrous oxide, N2O, nitric oxide, NO, and water. C plus O2 gives CO, carbon monoxide, which is neutral in nature. H2 plus O2 forming water H2O, which is also neutral in nature. So these are the examples of non-metallic oxides which are neutral in nature. They are neither acidic nor basic. So they neither turn blue litmus to red or red litmus to blue. Second reaction is reaction with water. Non-metals do not react with water or steam to give hydrogen gas. This is because non-metals cannot give out electrons to form positive ions. But this is contrary to the metals which readily react with water in different conditions, because they can form positive ions, they can react with water, but non-metals do not form positive ions and they do not react with water. Next reaction is reaction with acids. Non-metals do not react with acids to form hydrogen because they do not give out electrons to change hydrogen ions to hydrogen gas. Next property is reaction with hydrogen. Non-metals react with hydrogen to form corresponding hydrides. The conditions required for different non-metals are different. For example, first example is oxygen O2 plus H2 forms H2O, water, which is a liquid. These oxygen and hydrogen gases, they react when electric spark is produced in these gases. So they react to form water, H2O. Secondly, sulfur reacts with hydrogen to form H2S, hydrogen sulfide gas, and heat is required for this reaction. Third, nitrogen and hydrogen both are gases. They react to form ammonia gas, and the conditions required are 750 degrees Celsius temperature and 400 atmospheric pressure. Fourth reaction is chlorine reacts with hydrogen to form HCl gas. The condition required is diffused sunlight. So various non-metals, they react with hydrogen in different conditions and they form corresponding hydrides. Next is reaction with chlorine. Non-metals react with chlorine to form covalent chlorides such as HCl, PCl3, CCl4, etc. So first example is H2 plus Cl2 in the presence of diffused sunlight. These two gases react to form HCl or hydrogen chloride gas. Next example is phosphorus. P4 reacts with chlorine to form phosphorus trichloride or PCl3. So these are the various reactions of non-metals. So children, this is all for today. Thank you.